So, okay, this is just repeat. Now, there's a definition of substitution. So we substitute a term t for a variable v in a formula f, um, and we get a new formula. So that is formula obtained from the original formula by simultaneously replacing every free occurrence of the variable v by this term t. Okay, so here is an example. Suppose we have this formula that you saw before, um, has this free variable v x. Okay, so when you denote this formula by f of x, then we can substitute a for x and write f of a, and this is the formula where the free occurrence of x will be replaced by a. Now, so that's why there are three x's here. They are not replaced because they are bound occurrences. Only this occurrence is free. Okay, so sometimes people write this. In order to use this notation, you need to know what is the original formula and what is the parameter here. So to remember what is that original one, the free variable that we want to replace, we write x and dash a. Okay, but of course you can write either way too. Okay, so now let's define what is a semantics. So like propositional logic, we define what is an interpretation and apply this interpretation recursively over the formulas to say the formulas are true or false. And because we had so rich ontology of symbols in our signature, the interpretation also becomes a bit more complex. Okay, so here's a new thing in first order logic. We need to talk about the domain of the problem, okay, domain of the discourse, sometimes called universe as well. And this is a non-empty set. Okay, it could be infinite or it could be finite, but it cannot be empty. Okay, and there are also so that's one thing that we have to specify when we say interpretation of a formula, a first order formula. And the second thing is, of course, for every object constant, they are actually mapped to a member of this universe. So this C superscript I is an interpretation I applied to this constant C, and they can be members from this universe. Okay, so if we have John as an object constant, John superscript I tells you which member of the universe that this is the case. Okay, so note here that the object constant is not really the same as the names of the individuals in the universe. Okay, so when I say John, I can actually in principle map that John into a number in the numeric domain. Okay, so suppose this universe was a set of natural numbers and I have object constant John, then this interpretation may map John to say number 10. Okay, that's a perfectly valid interpretation. Okay, and even more, you can say that this universe is a set of names of people. You can map John to Mary, okay, by this interpretation I. That's also perfectly fine according to the semantics of first order logic. Okay, so that might be a bit confusing, okay, sometimes if you're not well trained to, but when you go on to some terminological knowledge-based system like some web ontology language like OWL, if you're not careful, then this kind of case may haunt you. Okay, so you may think that why this doesn't give this answer. Maybe it could be it's because you didn't know the difference between first order semantics and your intuition. Okay. All right, so after that we have this function constant, and function constant is a function from the some uh, Cartesian product here to some members in the universe. Okay, so basically if you have ordered pairs of argument, the function maps that argument into some member of the universe. Okay, so if I have some, let's say if I have father as a function, father of John. Okay, so um, John is an argument, okay, within the domain, and John is mapped to, let's say, Sam, okay, who is actually the real father. Okay, um, well, it could be number one. So father of John can be mapped to 1 if I is um, a numeric domain. Okay. All right, so for the propositional constants, they work like an atom, is also true. And for every pretty constant, same way, similar to function, but it returns actually true or false. Okay, instead of mapping to individuals in the universe, predicates are evaluated to be true or false. So here's a simple example that might help you understand the structure of this interpretation. So let's imagine that we have the set of universe, the universe to be the set of natural numbers. Okay, and so in this case, of course, I had to specify what are the symbols in the signature. Let's say A, P, and Q are symbols in the signature. A is an object constant, P is a unary predicate constant, and Q is a binary predicate constant. Okay. So there may be many ways to define interpretation. So here we are selecting very particular interpretation where the universe is a set of natural numbers. And under this interpretation, under this so-called possible world, I maps A to number 10. Okay, so A is a mnemonic name for number 10. Okay, and Pi, this is a function that is actually corresponding to this function here. Okay, so note here that this function, when I say this function f superscript I, f r superscript I, they're actually meta level function. They're not object level function constant in the signature. Okay, so this Pi maps each member of the universe into true or false. Okay, so recall that pretty constant returns given the argument, okay, which is coming from the n tuple of universe into true or false. Okay, here is 1u1, length 1 tuple, so each number can be mapped to either true or false. Okay, and the idea is this is to describe predicate. Okay, so I'm sorry, prime numbers. Yeah. So PIN is true if n is a prime number, false otherwise. And Q is a binary relation between the two numbers. So if m, the first one, is less than the second one, then it returns true, otherwise it returns false. Okay, note here that I could have defined A, so I could have defined a different interpretation. I doesn't have to be natural numbers, it could be real numbers. Okay, it could be even imaginary numbers, it could be people, whatever. Okay, I could have used different mapping depending on the different universe. The mapping could be also different too. Similarly for these two. So P and Q are just names here. The meaning was fixed by specifying which interpretation. So under this interpretation, P denotes the set of numbers. Under this interpretation, Q represent less than relation.